We are exploring a technology today that is literally rewiring how artificial intelligence works in the real world. Think about this for a second. I recently got a blood test done. When I opened the medical app to see my results, I didn't just see a boring PDF. I got a highly accurate AI-generated summary of my report, along with FAQs specific to my personal health data and tailored medical suggestions. Now, standard large language models like ChatGPT or Gemini, they simply cannot do this on their own. They don't have access to your private, real-time medical records, but the AI in that app did. How? It's all thanks to a game-changing framework called RAG. Let's dive into exactly how this technology gives AI a massive brain upgrade.
So, here is our roadmap for this explainer today. We're going to cover 1. What RAG actually is. 2. The 4 key benefits. 3. The data ingestion pipeline. 4. The retrieval and generation pipeline. And finally, number 5, we'll look at 7 distinct RAG architectures. Lots of ground to cover, so let's get right into it.
Section 1. What is RAG? The Open Book AI Revolution.
To really understand why this is causing such a massive shift in tech, there's a fascinating analogy we can look at. Imagine 2 students taking a tough exam. Student 1 represents your standard LLM. They read millions of books before the test, sure, but the exam itself is strictly closed book. They have to rely entirely on whatever they managed to memorize during their training, and their knowledge basically froze on a specific cutoff date. Not ideal, right? Now look at student 2. This student represents an AI using RAG. They are taking an open book exam. Whenever they get a question, they can actively flip through real-time databases, verify their facts instantly, and pull the exact, most up-to-date information before writing down their answer. Naturally, student 2 is going to perform significantly better with way fewer mistakes.
And that brings us to our definition. Retrieval-Augmented Generation, or RAG for short, isn't actually a standalone AI model, it's a technique. It allows your AI to retrieve context from a specific database right before it generates its response. This makes the AI deeply context-aware. Imagine your flight gets delayed. If you ask a standard AI chatbot, hey, why is my flight delayed? It's just going to give you a generic guess because it has no idea who you are. But if you ask a RAG-powered airline chatbot, it retrieves your PNR, checks the real-time weather at your specific destination, and tells you exactly why your specific flight is grounded. It beautifully bridges the gap between generic intelligence and specific reality.
Section 2. The 4 key benefits of RAG. Why the industry is upgrading.
Moving from the conceptual side over to the practical side, let's look at why massive enterprises and small businesses alike are entirely restructuring their AI systems around this framework. There are 4 huge benefits here. First up, RAG drastically reduces AI hallucinations. You know those moments when an AI confidently just makes up fake facts? RAG forces the AI to ground its answers in retrieved real-world documents. Second, it keeps knowledge infinitely up to date. You completely bypass those frustrating knowledge cutoffs, like September 2024. Third, it is incredibly cost-effective. You don't need to spend millions fine-tuning some massive model. You literally just update the database it reads from. And finally, data privacy. Because the AI only looks at chunks of data relevant to the prompt, your company's highly sensitive internal databases are never exposed to the public training pool of the core LLM.
Section 3, the data ingestion pipeline, preparing the open book.
So for our AI student to actually take that open book exam, we first have to write and organize the open book itself. Let's break down this ingestion pipeline step by step. Step 1, we extract our raw data. This could be hundreds of company PDFs, internal records, website FAQs, the whole shebang. Step 2, we take that massive pile of data and split it into smaller, manageable pieces called chunks. Now, step 3 is where the real magic happens. We convert those text chunks into vector embeddings. Let's translate that technical jargon. AI models don't actually read English text, they only understand numbers. So embeddings are just a clever way of translating our human sentences into long arrays of numbers that capture the core meaning of the text. Finally, step 4, we store all those numbers in a specialized vector database.
Now, what's really fascinating here is how a vector database fundamentally changes the way search works. Standard databases rely on exact keyword matching, but a vector database uses semantic or meaning-based search. For example, imagine you are searching a medical database for heart attack symptoms. A normal database is only going to return documents that have those exact 3 words. But a vector database understands the actual meaning behind the numbers. It'll pull up documents on cardiac arrest, even if the words heart attack are literally nowhere in the text. This incredible ability to search by meaning is the absolute foundation of why RAG is so accurate.
Section 4,
The retrieval and generation pipeline, answering the user query.
Let's move to the other half of the equation and see how this all comes together when a user actually sits down at the keyboard and asks the AI a question. 4 things happen in just a fraction of a second. First, the user's question gets converted into an embedding, again, turned into numbers. Second, the system runs a semantic search in our vector database to find the most relevant document chunks. Third, we take the user's original question and we augment it, meaning we combine it with those specific facts we just retrieved. And finally, step 4, we hand this supercharged, fact-filled prompt over to the LLM so it can generate the final answer. And honestly, this brilliantly illustrates where the name comes from. We retrieve the facts, augment the prompt, and generate the answer. Retrieval-Augmented Generation.
Section 5. 7 popular RAG architectures, scaling from basic bots to enterprise AI.
All right, now that we understand the core engine under the hood, let's rapidly explore 7 ways the industry scales this up to solve complex business problems. First up is naive, or standard RAG. This is exactly the pipeline we just finished tearing down. It's a fantastic low-complexity setup. If you run a retail website and you just want a chatbot that can cleanly answer customer questions based on your return policy and basic FAQ documents, standard RAG is for sure your best friend.
But what if you need more precision? Let's contrast our next 2. First, we have hybrid RAG. Semantic search is amazing for meaning, but it's terrible if you are searching for an exact product serial number. Hybrid RAG solves this by combining meaning-based vector search with traditional exact keyword matching, making it an absolute must for e-commerce. Then on the flip side, we have graph RAG. Standard RAG treats data chunks independently, which is pretty bad if you need to track complex relationships. Graph RAG actually structures your data like a giant web of connections, nodes, and edges. If you're doing intense legal research or building a fraud detection system that needs to see how different people and shell companies connect, graph RAG is exactly what you use.
Tucked in at number 3 is RAG with memory. The thing is, a standard pipeline kind of suffers from amnesia. It instantly forgets the last question you asked. So if you ask a standard bot a highly detailed question and then follow up with, "Can you explain more about it?" the AI has absolutely no idea what it is. RAG with memory adds a dedicated layer just to maintain a running thread of the conversational history, which allows for truly natural, human-like support assistance.
Number 5 is where things get truly autonomous, Agentic RAG. Imagine asking an AI, explain the 2025 gold price hike and compare it with other metals. A single database search just cannot answer that. Agentic RAG gives the AI the autonomy to break that complex query down into smaller steps. First, it realizes it needs the 2025 timeline. Then, it autonomously uses a live finance API tool to pull other metal prices. It executes multiple independent retrievals across entirely different external tools, pieces it all together, and hands you a comprehensive analysis. It's like having a dedicated research assistant.
At number 6, we have multimodal RAG. Up until now, we've really only talked about text, but the real world is visual and auditory. Multimodal RAG can process and retrieve way beyond just text, seamlessly integrating images, videos, and audio. This has unbelievable utility in the medical industry. An AI can now process a patient's visual X-ray scan right alongside their textual medical history to assist doctors. Or it can seamlessly analyze live video feeds for security and surveillance.
Finally, number 7, self-reflective RAG. In this architecture, the AI flat-out refuses to give you its first draft. Instead, it generates a draft and then acts as its own harshest critic. It actively analyzes the response against the retrieved context to verify absolute accuracy, catches its own mistakes, and actually improves the answer before you ever even see it. For highly regulated industries like legal compliance or heavy scientific research, where a single hallucination could literally be disastrous, this architecture is a massive game changer.
Well, we've covered a tremendous amount of ground in this explainer today, from the fundamentals of the open book AI revolution, down into the ingestion pipelines, and all the way up to advanced architectures like Agentic and self-reflective RAG. I want to leave you with this question to really think about. Looking at your specific industry and your daily workflows, which of these 7 RAG architectures will solve your biggest AI bottleneck? Let me know your specific use cases in the comments below. Thank you so much for exploring this with me today, and I'll catch you in the next one.
Welcome to SGIT Meister, or your go-to IT technology guide. Like, share, comment, and subscribe for more powerful tech updates.